You need to write down everything because it is, well, it's not really complicated. Once you get the hang of it, it turns out to be pretty easy. The problem is it works in a lot of all this radical stuff that we're doing in the bell work. So I do those bell works for a reason, okay? It will be helpful to look at those bell works while we're going. So today we're talking about special right triangles. Special right triangles, we have two types of them. They are a 45-45-90 type of triangle and a 30-60-90 type of triangle. And this stuff today is what I would call the shortcut way to do things, okay? And we like to teach this because turns out to be pretty quick. You can get pretty good at it. Today is the day where you learn how to do that. So is it going to be easy right off the bat? No, because you've never seen this before, okay? This is very sort of different, shall we say. Now, this stuff is very important in the building trades. So in construction, of course, we've got 45-45-90 triangles and 30-60-90 triangles all over the place. And so they become quite useful in the building trades and in trigonometry. I'm sorry, not trigonometry, architecture. Now, the problem I have with geometry is they throw this in here at this level, and I don't like just giving you information. I want you to know where these numbers come from. Ladies, okay. So I'm going to start by giving you where it comes from. So I'm going to start with a square. And this is a square. I'll draw the square. All right. Tell me what you know about squares.
It has 4 right angles.
4 right angles and... Okay. And all 4 sides are congruent?
Yeah.
Okay. So that is a square. And to get us started there, I'm going to start off by saying that this is a square of side length 1. Okay? So all 4 sides on that square have a side length of 1, and I'm just choosing some nice numbers here, just again so you can see where these things come from.
Side lengths would have to be 1.
They're 1 as well. So what I'm going to do is I'm going to take that square, and I'm going to draw a diagonal. Now when I draw in this diagonal, what happened to those 90-degree angles? They split into 45s. Oh, okay. So guess what I just created?
A hypotenuse.
2 right triangles, 2 45-45-90 triangles.
So what the hypotenuse?
Hold on. Let me get there. No.
Oh.
No, it doesn't equal 2. So the question is, we want to figure out what is the length of the hypotenuse. All right? I'm going to use h to represent the length of the hypotenuse. So I have a right triangle, and I have side lengths here. So can I use the Pythagorean theorem?
Yes.
Yeah. So I'm going to say leg squared, so 1 squared plus another 1 squared is going to equal my hypotenuse squared. All right. I know this is really challenging. What is 1 squared?
1.
1. So we have 1 plus another 1, and that gives me 2
Which
equals the hypotenuse squared. How do I get the h by itself?
Square
root both sides, and so we get the hypotenuse is equal to radical 2. That hypotenuse, the diagonal of a square, is radical 2 times the length of the side. All right? So the radical 2 is the length of that hypotenuse, and it turns out radical 2 is a number. It's like 1.4 something or other, okay? Every 45-45-90 triangle is similar to this one, with side lengths 1, 1, radical 2. And all we've done is said, hey, this triangle is 8 bigger. It's times by 8 bigger. So I take my 1, 1, radical 2, and I just multiply all those by 8, and I'm done. Okay? So, to summarize, really need you guys to pay attention. All right. To summarize, we have a 45-45-90 triangle. Because the angles are the same, we also have congruent sides every single time. 2 congruent sides. For any isosceles, not any isosceles, our triangle is isosceles here, which means both of these sides are some length x. In this triangle, they were length 1. We're using x to represent any side length, okay? All I have to do to figure out the length of the hypotenuse is take that side length and multiply it by radical 2. It is radical 2 times longer than those legs. So our leg we call x, they're both legs, and then the hypotenuse, we just take that leg length and multiply it by radical 2, and that's all we have to do. The problem is we don't always just go in one direction. Okay, so I have a little graphic to help you out here. In this 45, 45, 90 triangle, we have a leg and we have a hypotenuse. Those are the only 2 things we have. We have the leg and we have the hypotenuse. If I know the length of the leg, to get to the hypotenuse, all I have to do is times by radical 2. That's all I have to do. Curtis. Come sit right here. If I'm at the hypotenuse, how do I get back to the leg? Divide by radical 2. That's all. Divide by radical 2. That's what we have to do. We either multiply by radical 2 or divide by radical 2. Okay, let's see how that works. We have a 45, 45, 90 triangle here, which means both legs have to be, and they are equal, which means x is 8. Okay, so we have an 8 and 8. So I have my leg length of 8. What do I have to do to get the hypotenuse? Yeah, just times that 8 times by radical 2. I encourage you to just draw it right on the triangle. You don't need to fill in the things, but I will. 8 radical 2. It's really not hard. It's weird, but it takes some time. All right, it takes some time to get used to. This is solved. You're done.
Solved, so it's not 11.
No decimals. No decimals today, ladies and gentlemen. No decimals. All right, number 2 here, rather. It's a 45, 45, 90 triangle, which means we have 2 congruent legs. What is y? 25. All right? So we have the legs. How do we get to the hypotenuse? Yeah, the leg times radical 2. That's all it is. So in this case, the y was 25 and the x is 25 radical 2. Is this easy or hard? This is not too hard.
Is it 19 radical 2?
No. So number 3 is different. Number 3 is different. What information did they give us on number 3?
They gave us the hypotenuse.
They're giving us the hypotenuse of 19. So we're here at the hypotenuse. How do I get back to the leg?
Divide.
Yeah, we have to do 19 divided by radical 2. Now, this is a no-no. We can't have radicals in the denominator, so what do we need to do?
It's the thing that you told us.
Rationalize. Rationalize. I'm going to write that down. Rationalize. R-A-T-I-O-N-A-L-I-Z-E. So, hold on. We're going to multiply top and bottom by?
Radical 2.
Radical 2 on top and bottom. Multiply top and bottom by radical 2. And so in the numerator, that's easy. It's just 19 radical 2. What's radical 2 times 2? Radical 2. Radical 4, which is 2. Radical 2 times radical 2 is just 2. All right?
You can't simplify that.
And you can't simplify that. So 19 does not divide evenly by 2. So, yeah. And both of those happen to be the same. They're always going to be the same. So 19 radical 2 over 2 is your answer for both of these. 19 radical 2 over 2. Okay, so that was a divide by radical 2. Questions on those? Again, it's just a little bit weird to get used to. The hard part is with all the radicals, really. All right, let's look at the 30, 60, 90. All right, so for 30, 60, 90s, once again, I'm going to tell you where these things come from. So for a 30, 60, 90, I'm going to start with an equilateral triangle. What is an equilateral triangle?
One leg that's taller than the other.
No.
Oh, wait, no.
All three sides are the same. Okay, equilateral, all three sides are the same. In this particular case, these side lengths are going to be 2, okay? So we have sides of length 2. If all three sides are the same, what else is true? All the angles are the same? Yes, that's very good. All three angles also have to be the same, which means they are how much? 60. Very good. 180 divided by 3 is 60. So we have 60-degree angles all the way around. Now, what I'm going to do then is create a 30, 60, 90. I'm going to drop an altitude down.
Great.
So now I've got a right angle here. What do you think happened to this 60-degree angle?
It becomes 30.
It got split in half. So now we've got two 30-degree angles there. So now I have a 30, 60, 90 triangle. What happened to the side that was length 2? They're each a 1 now. It got split right down the middle. Okay? Now, we have, once again, a right triangle, and I can use the Pythagorean theorem again. I want to figure out this, I'm just going to call it R because it's red. I want to find this length R. And I can do that with the Pythagorean theorem. So 1 squared plus r squared equals 2 squared, equals the hypotenuse squared. 1 squared is 1 plus r squared equals, what is 2 squared? 4. And I need to get r by itself, so what should I do? Subtract 1, good. So we get r squared equals 3. And then how do I get r by itself? Square root both sides, very good. And so you get r equals radical 3. Ladies and gentlemen, the length of that longer leg is radical 3. And so in this 30, 60, 90 triangle, we have side lengths of 1, radical 3, 2. Okay? Kind of interesting. When you look at your 30, 60, 90 triangle, we're going to base all our answers on the short side. We have to know the length of the short side. In this particular case, I'm going to call it X. Question?
So, like, it's reflexive, right?
Reflexive.
Like the triangle is reflexive.
Yeah, it is a reflection.
Yeah, so, couldn't you, like, do, like, 60 degrees and then divide that by 2? Like, if you get the final answer and then divided by 2 if you use the 60, 60.
We'll have to come back to that.
Okay.
Okay. So to get this longer leg, because the 60-degree side is going to be opposite the slightly longer leg, we just take our short leg and we multiply it by that radical 3. You'll notice the short side is 1, the hypotenuse is twice that. So when we have our short side, if I want the hypotenuse, all I have to do is 2 times the short side. Okay? So the shorter leg is x, the longer leg is x radical 3, and the hypotenuse is twice the short leg, or 2x. I don't really like that. Again, I'm going to draw you a picture. So once again, I have a little graph here to help you out here. Once again, this one, 30, 60, 90 has 3 parts. We have the shorter leg, the longer leg, and the hypotenuse. So we have the short leg, the longer leg, and the hypotenuse. If I have the short leg and I want to get to the longer leg, what do I need to multiply by? Radical 3. So we multiply by radical 3. If I'm at the longer leg, how do I get back to the short leg? Divide by radical 3, yeah. All right. If I have the short leg and I want to go to the hypotenuse, times by 2. if I'm at the hypotenuse, how do I get back to the short leg? Divide by 2. All right? So we're just going to follow this little graph. We always have to go back to the short leg when we do a 30, 60, 90. So on number 4, what information did they start me with? The short leg. Good. So we're starting with our short leg, which is a nice place to start. How do I get the longer leg? Times by radical 3. So we're going to take our 5 and just multiply it by radical 3. Right there. That's all we have to do. Now if I have the short leg and I want to go to the hypotenuse, times by 2. So I take my short leg and times it by 2. And that's going to be your hypotenuse. So in this case, my x is 5 radical 3, and my y is 10. Okay. On number 5, what information did they give us? The short leg again. Great place to start out. How do I get the longer leg?
14 square root 3.
14 times by radical 3. Easy. Short leg to hypotenuse?
28.
Times by 2. So 14 times 2. Times by 2. So 14 radical 3. And the x is 28. All right, how you doing with this? Okay? All right, what information they give you on number 6 here? Yeah, they've given us the hypotenuse here. So we're starting here with the hypotenuse. What do we have to do from the hypotenuse?
Divide by 2.
Divide by 2, and that's going to give me 16, yes. Where? The x, yeah. There's the short leg. So 32 divided by 2, the x turns out to be 16.
And then 16 square root.
Yeah, and then we have the short leg of 16. Now we just do 16 times radical 3 to get the longer leg. Okay? So always get your short leg and you're good to go. Number 7, once again, they gave us the hypotenuse. So we're starting at the hypotenuse. What do we have to do? Divide by 2, and that'll give me my short leg. So my short leg is over here. So 46 divided by 2 is 23. And now that I know the short leg, how do I get the longer leg? Times by radical 3. So 23 radical 3. All right, now for the really tricky ones. Number 8 and 9. On number 8, what information did they give us? They're giving us the long leg. So we're here at the long leg. What do I need to do to get the short leg? Divide by radical 3. So my short leg would be 20 divided by radical 3, but I can't divide by radical 3. What do I have to do? Rationalize, yeah. So what are we going to multiply by? Radical 3, top and bottom. So the top is easy. That's just 20 radical 3. What's radical 3 times radical 3?
3.
Radical 9, which is 3, yes.
So if it's like a prime.
The 3?
Yeah, if it's like a prime number, do you have to can't you just take the radical out?
So like radical 3 times radical 3?
Yeah, so if it's like radical 3
Mm-hmm.
radical 3.
Yeah, it's just 3. It's always just going to sit. Radical 25 times radical 25 is just 25.
Yeah.
So that's not even prime.
Okay.
Doesn't matter. So that is the pattern. The radical just goes away. And the reason is because it's radical 25 and we're squaring it. So the square root and the square cancel out, and so you're just left with 25. This is another way to think about that. Okay, yeah. All right. Okay, now we have the short leg. That's the y there. That's really complicated. 20 radical 3 over 3. How do we get the longer leg?
Multiply that by 2.
We got to multiply that. Yeah, we got to times it by 2.
So 40.
Yeah, that's a tricky one.
Radical 6.
So careful. We're going to times it by 2. First of all, I want you to realize that that's a 2 over 1. And you can only multiply like kinds of numbers together. So we're going to do 2 times 20. That's going to give me 40. I can't do 2 times radical 3 because they're not friends. Okay, so it just stays a radical 3. And then the denominator is just 3 times 1, which is still just over 3. So when we times by 2, we're just multiplying the numerator by 2. Just the regular number by 2.
Wait, so it's the one in orange, not the one in green, right?
The y is the orange one, and the hypotenuse, the x, is the green one. Yeah. I know. They need a little more space here. All right, let's look at number 9. What information did they give us?
The leg, but it's already in radical.
Yeah, the long leg is where we're starting here. How do we get to the short leg?
You just take 9.
Why?
Because it's already radical 3.
Yeah, we got to divide by the radical 3. So 9 radical 3, we're dividing by radical 3. And this one's nice. What happens to those radical 3s? They cancel. So you just get 9. And then how do you get the hypotenuse?
9 times 2.
9 times 2. Double that to get to the hypotenuse. So we just get 18. All right, please work hard on your delta math. It is a little bit weird. So please ask questions. And again, on the first ones, figure out what biggest perfect square divides evenly. So use your calculators and find that large perfect square that goes in nice.